Hey everyone, it's Jim again. Welcome. So, thanks everyone for joining this meetup. For those of you who have been members of our meetup group, we started this group, it was fall of 2014 when we did our first meetup. And we've been mostly doing in-person live meetups, but we've had some requests for some online sessions too. So we're going to give this a try. This is our first online meetup, although we've had, I guess quite a few, about 20, 30 other live sessions at various locations in Silicon Valley. So thanks again for joining. Our topic today is something, which a lot of the members have expressed interest in as we're getting started with containerization and microservices. Now, obviously, the focus of our group has been cloud-native applications, but as we know, a lot of us today have applications which are fairly traditional, and there's a desire to move them towards, a cloud-native form factor or cloud-native architecture. So we're going to discuss a little bit of what can be done with these traditional applications, how you can, leverage some of the benefits from newer technologies like containers. And what that means to the application itself. So just to quickly introduce, the speakers today. It will be myself and Ritesh Patel, my co-founder at Nirmata, who will be presenting. And what we're going to do is we'll do a few slides up front to set the context. We're going to try and show as much as possible in terms of a demo, where we go through an application, which is a stateful application. We look at how that's containerized and look at deploying and operating it in multiple clouds. We will use Nirmata for the demo, and but this, of course, you can use other container management orchestration tools, and we're not going to really focus much on Nirmata, so feel free to reach out later if you have any questions about it or any specifics that you want us to answer. But just to quickly introduce, what we do at Nirmata and what our focus is. So we started Nirmata late 2013 to help everyone really migrate to cloud DevOps type of best practices. And there's a few unique beliefs we have which have really shaped our vision for the product. And we continue to drive, based on that and based on, of course, feedback from the community and from the group itself. So first off, we believe that software infrastructure, much like critical infrastructure in the real world, is best delivered and operated as a service. Secondly, we believe that cloud-native applications need cloud-native management. You can't really take installed packaged software and expect to manage multi-cloud or cloud-native applications. And lastly, one of our core beliefs is that applications and developers should not be locked into cloud providers. So much like in the past we had infrastructure stacks, now we have cloud providers as the new foundational stacks. And we don't, we want to make sure that DevOps teams, developers everywhere have the flexibility to choose any cloud provider they need as much as possible. Now, this doesn't mean it's all seamless. There are, of course, some challenges, and we'll discuss this as we go along. Okay, so diving into the topics for today and what we want to cover in this session is, first off, we want to look at, does it even make sense to containerize traditional applications? So in most cases, you might have taken a 3-tier application, maybe you packaged it as AMIs if you're using AWS, or VM templates, and things are working fine. So why bother, right? Why even mess with what's working and containerize it? Secondly, we want to kind of try and address, well, can they be containerized? If, once we agree that there's value, can these be containerized? And lastly, we want to go through what are the steps and what are some of the gotchas and pain points in containerizing versus and the best practices as you approach this. We will do, like I mentioned earlier, we'll take a stateful lab, we'll show this in a demo, and then we want to make sure that we save time for Q&A also. So one thing I should mention on the Q&A is you should see in your GoToWebinar panel that there's a questions tab. So feel free to enter questions anytime Based on the timing we have, we'll answer them as we go. If we run out of time, we'll just save the questions to the end, and Ritesh and I will stay on and we'll answer questions all the way through.
Hey Jim, before you move on, how about a quick poll of what folks are trying to containerize? So why don't you guys take a few seconds to just respond so that we get a good idea of what kind of applications people are containerizing or interested in containerizing, and we can tailor the questions or tailor the presentation accordingly. All right, I think we have a reasonable amount of responses. I'm going to close the poll. Let's quickly see the results, and here are the results. So it looks like a lot of folks are trying to containerize. Okay, so it looks like 52% is custom applications. Let's continue. If you didn't see the poll, we'll probably share the results later.
Wow, that's yeah. So 52%. It's a fairly good mix of people starting with new apps, and then folks taking existing apps and trying to containerize them. So this should be a great discussion as we go through it. All right, so let's try and answer the why, right? So we need to get that out of the way first. And what we'll do, and I'm sure a lot of you have seen all these benefits of containers in other articles, blogs, and meetup sessions. But just to quickly recap, right? So we all know containers are fast. They're fast to deploy, fast to pull in changes because of image caching, etc. And as you're going through, especially as you're going through a DevOps lifecycle, developers, like myself, as we make changes, as we are testing things in a QA environment or in a dev environment, we might be doing hundreds of deploys during a single day, and every second, every millisecond, or every few pauses here and there, all of those will start adding up, right? So that agility just really increases your efficiencies in the DevOps cycle. Also, from a end-to-end perspective, as you're deploying things, being able to get things into production faster makes a huge difference in being able to innovate, being able to experiment. So speed is usually always the #1 factor. Portability is also very interesting and a huge benefit here, because and it's not so much about as being able to just seamlessly operate your application on any cloud, but at least knowing that you're not locked into one set of infrastructure or another, and you have the option of running the same application, whether it's on your laptop, whether it's in a private cloud, public cloud, etc. Consistency is another benefit which comes from the whole best practice of immutable images and being able to bake these images as part of your CI/CD or your build tool chain, and then being able to make sure that the exact same image is deployed every time you do a deploy of that application and that version of the container or containerized image. In terms of control, containers and the whole container ecosystem, so container services, are providing a much more flexible and much more open option to traditional platform as a service type of approaches. So here with containers, developers can control exactly what goes in a container. So you have the flexibility of choosing any language, any tool, any backing service that you wish, any database, so on, and being able to deploy it in any cloud of your choice. From an operations point of view, you also get a lot of more control than you would with a traditional VM or with the cloud instance in being able to manage resources. Interestingly, there's a recent article from, and this was a on a report from Gartner where they said even for security, containers now provide a lot more knobs and options. So if you do follow the best practices, you can make a containerized application even more secure than a non-containerized applications because of that. And then finally, efficiencies, right? And this, I'm not talking about just, the speed, but I'm talking about resource efficiencies, where because with containers there's a high degree of automation, you can have that automation layer, usually your management and orchestration, ensure that you're getting the right utilization from your cloud resources. So all of these add up. But don't just take my word for it. Let's look at a couple of real-world use cases, right? So this case study is something that Docker published a few weeks back, about maybe a month back now. So this was talking about, Sean, who's a cloud architect at Cornell University. What he blogged about is just containerizing a very traditional Confluence application, which they use for the university blogs and wiki type of site. And this is, it's an Apache Java application. It was not something which, was, I mean, it's critical. It was an important piece of their infrastructure. It was not something that was, which took up a lot of time or resources. But even then, even with containerizing it, just some quick calculations that they did, is that in a couple of months to get this containerized and out into production, they were able to see a 10x improvement in the time they would spend on managing upgrades, managing the system itself. Now they could do that a lot faster and get some of these other benefits that we were talking about. Another example that I want to provide is, it's a customer of ours at Nirmata. This is VMware's IT applications team. And we did a webinar with them. I posted the link over here. And what they're seeing is just by taking, this was a LifeRay application run in a private cloud and with a lot of custom developed, code on it. And this provided them with almost a 48x productivity gain, right? So a lot of this was, again, in the DevOps lifecycle as they were going through deployments of these instances as they wanted to debug and test environments. Now they were able to do this in minutes versus, what used to take hours to bring up a single environment.
So Jim, why this difference in productivity gain? I mean, what do you think the 10x versus 48x?
Yeah, no, good question, because that is a big gap, right? So one of the first example we looked was an application which is more of a third-party application, which was containerized, right? And certainly 10x is a significant productivity gain there and lots of hours saved. Maybe on the cost savings, it doesn't add up to that much, but still a significant boost. The second application we looked at was more a custom developed with a lot of code involved that the team was creating. Now, like we were talking about, if you're developing custom applications, you spend a lot more time bringing up and tearing up environments, and containers really start to shine over there, right? So, in fact, we have heard of people using containers just for dev test, and then maybe even still deploying applications as VMs in production just to get that significant productivity boost in dev test. And then later they're going to kind of revisit containerizing all the way through and deploying those as containers even in production. So to answer the question, can these be containerized? Absolutely yes, right? So we just looked at two traditional applications, which one was a LifeRay portal with a lot of custom developed code around it. The other was a Confluence site, which were fully containerized and operated through container management systems. Then you might want to do this. Now, if you have an application which is not taking up much time in maintenance and it's a third-party app, maybe the benefits are not that great. Well, you still could get portability and other things. But if you are spending time, even if it's every few months, you're spending a day or two, just with the maintenance cycles, etc., it's a good idea to try and think about containerizing. Certainly for custom developed apps, I mean, hands down, you're going to see huge productivity gains almost right away with containerizing. So that's where now, if you have a monolith app, which is fairly simple and doesn't have any complex configurations or other needs, perhaps the gain is not that big, but even then, you will start seeing value through the portability and the automation and the resource efficiencies that we talked about. So good set of trade-offs to think about, but absolutely these applications can be containerized. Now, one thing I should pause and say right here is we're still talking about Linux applications, and it is very possible to containerize. And in fact, we're starting some work and doing some partnerships with a company called Windocs, which is doing containerization of SQL Server and Microsoft applications on 2008, 2010, and 2012 servers. Microsoft themselves are working on, native container support for Windows 2016. So those are also possible to containerize, but here our focus still mostly is on Linux platform applications.
A couple of questions. So Jim, we have a couple of questions on our chat. So what when you containerize, what about things like patching and security patches and things like that? How do you do that? And does containerization help or harm, or any thoughts on that?
Yeah, very good question, right? So two things to point out, and definitely the blog post that I shared from Sean at Cornell. It also talks about patching and security and what they had to do in terms of maintenance there. But first off, yeah, containerization, within the container itself, you can decide what libraries and what you want to include. So you still may end up having to do some OS or host management out of that, but it becomes a lot easier now to stay up to date because you can easily bring up, and we do this at Nirmata all the time, is if you want to bring up a brand new instance with new libraries, even a completely new OS, and then you can deploy that same container which has perhaps some libraries of its own in there, right? So my point there is you get now more control over what you want to put in the container and manage as the container lifecycle versus what you want to put as in the OS and manage at the operating system level. And you can take that same immutable image, which you knew was working before, and move it to a new OS and quickly test it out, right? So it gives you more flexibility. The other question on the security side, I mean, absolutely, there are also benefits there. Because with image scanning and things like image signing and verification with a lot of registries, so Claire from CoreOS is a free and open source tool you can use to scan any image. All of these tools build on top of other tools in terms of detecting vulnerabilities and compliance to best practices. And Docker Data Center also includes some of these tools with their image registry. So you get a lot more proactive scanning and management. So, and I think both of those can be helped with containerization.
Great. There's one more question. Actually, can you repeat the tool you mentioned for scanning images?
It's Claire by CoreOS, and we can put in a link into chat, or certainly feel free to reach out afterwards if you wish, and I can share details on that.
And also regarding creating container images, can you elaborate on how the layered file system and the layered images help when building these applications? Between developers and ops teams, how would you manage and control that, right? Again, from a patching and making sure the OS is updated perspective.
Right. So, once again, it's important to, if you do have a handoff between dev and ops, right? So it's important to delineate which packages your application developers will control versus what the operations team will control and manage as, let's say a build image or a approved image to run on. So that varies by application, but it's fairly straightforward to some degree because, again, if you're building, let's say a Node.js app, there would be a set of dependencies and things you would need to just run that app. If it's a PHP app, similarly, you pull in the right PHP libraries, etc. So those things you control of, and you don't want every time they change a library to have to go and involve multiple teams to just enable that. At the same time, there will be other components which you want to make sure stay within the maybe outside of the container, and these you could either do as a layered file system, like Ritesh mentioned. So one good best practice is perhaps the ops team also builds a base image for a container. So you could have a PHP-based image, a Node.js-based image, which includes all the up-to-date versions, or perhaps you just do it based on OS. So you could even start with an Ubuntu or a Alpine Linux based image, and from there on build on more of the packages that you need. So it varies from team to team, but it's finding that a balance between what you want the dev team to control, what you want the ops team to control, and allowing the flexibility and agility on both sides. Okay, so let's dive into some of the considerations and key points in containerizing these type of applications, right? So there's 5 items I want everyone to think about and kind of take away in terms of what you have to address to containerize an application. The first one is application state, and today we're going to spend most of our time discussing state and looking at this. The next one is trying to decompose and see, even for traditional apps, there are some natural seams, perhaps at every tier, if you have a 3-tier app, or perhaps there's other components even in your middle tier, which can be containerized separately, right? So understanding whether you're going to put the entire application into a single container or break it apart into a few containers is something you need to decide. And then beyond that, it's the networking, storage, and security needs that you need to think about as you approach containerizing. So once again, today we're going to spend most of our time on application state because that's perhaps the most challenging. But what we will do at the end of the session, we'll do a quick poll on what follow-up sessions we want to do. And we're happy to deep dive into each one of these areas, especially things like networking and security, where we know there's a lot of interesting things and trends going on, and we will bring in other experts too into these sessions to as we discuss these. So let's talk about state. So one common thing that I keep hearing all the time, and I'm sure you've heard too, or maybe you even said this because we've read it so many times, is you hear something like, hey, containers are ephemeral, containers have a quick life cycle, so they're really only good for stateless or microservices type applications. Now, containers are great for microservices style applications. They're a natural fit for that, but by no means they're limited to those type of applications. You can, and what we'll show today is you can take almost any application that you can install on Linux can be containerized. There are some challenges, and there may be things you have to think through, and depending on your orchestration management system, there might be some, again, limitations in what you can do when it comes to networking, storage, and security, but it's not really a container issue at that point. It's more of an issue of the processes around that, right? So let's dive deeper into this, and let me try and show you why state is not an issue when it comes to containerization. So first off, every application is stateful. Regardless of whether it's a traditional application or a microservice application, on the whole, applications have behavior and state. And based on your architectural style, based on your programming languages, There's different techniques and different ways of dealing with behavior and state, but ultimately every application has behavior and state. In a three-tier application, you might be delegating your state to something like a middle tier. In a microservices-style application, each service is going to manage its own state, most likely, again, delegating it to a database or some sort of caching or other tier. And each service here is designed for elasticity. So you can safely say in a microservices application, each service, each microservice is stateless, but the application itself has state, and that needs to be managed. So what kind of states can an application have, right? So there's the major kind of state an application has is typically persistent or data, right? That we're storing domain data that we're storing on behalf of customers, on behalf of the end user of the application. So typically that's persistent state, which goes in a database. You also have configuration state, which is the bootstrapping required for the application itself to be configured on a particular set of hosts or cloud instances, wherever you happen to be running it. There could be session state and connection state, which has to do with networking for the application. And finally, there could be cluster state, which is if you're running things like a database or perhaps a messaging system, or other clustered software like Zookeeper or Kafka, they would have some cluster state that needs to be managed for the application. So let's look at each one of these and try and figure out how do you deal with these state, this type of state when it comes to containerizing them, right? So the first one and the most important and common one is persistent state. So this is once again, it's domain data that your application is managing, typically on behalf of end users. If you're running a SaaS, this could be multi-tenant. If it's a traditional app, maybe it's just the user data that you need to manage. Now, if you do put state into containers, and sometimes there's good reasons for doing so, obviously the state is going to disappear, or maybe it's not that obvious, but the state is going to disappear when the container dies, right? So that doesn't, for this type of state, persistent state, that's not a good thing. The next option is you could say, well, I'm not going to put my data in my container, but I want to manage it with my host or my VM, in which case you would use a volume that's just created on the host, however you wish, right? So through your existing tools, through your orchestration system, or even volume plugins. But at that time, now the life cycle of your state or your data is attached to the VM. And lastly, the other way you could manage state is you could completely decouple it from your hosts as well as your containers by using network file systems or network volumes, or if you're using a cloud provider, you can create and manage volumes independently of your hosts, and leverage your orchestration systems for this. So 3 different choices at a high level, right? And there is a 4th choice, which is, of course, you could programmatically connect to things like an object database from inside your container, but it's not commonly used except for some applications. So I'm not going to discuss that in too much detail here. But just to kind of recap on this and emphasize, how you might want to manage your databases in your database state. One best practice is to try and separate this tier from your, or separate the life cycle of your data from your applications, right? This gives you the most benefits. So if you can bring, you want to bring up and down your applications, you can keep your data running. You could even, start by running your data tier on a separate set of VMs or hosts, which are not containerized, but then over time containerize it. Looking at those 3 choices, the host volumes are really good for smaller sets of data. So if you're doing, things like you have a MongoDB instance, it has some configuration data, and if the replica can come up on any host and sync up with the cluster, use host volumes. They're perfectly fine for that use case. If you have larger sets of data which you need to manage independently, and it's not practical to sync up with the cluster, or maybe it takes quite a few minutes or hours to do that sync, then you want to start considering managing volumes independently of hosts, or putting things on a network file system. Even if you're using Amazon, you can use their Elastic file system, and that state will persist or stay independently of host state. So many different choices here on managing persistent state. Next, let's quickly talk about configuration state. Now, this is typically non-domain data, which is needed by the application. So there's two classes of this I want to touch on. One is there's typical configuration data, could be things like IP addresses, domain names, DNS names, which you need to bootstrap your application. And there's another class of configuration data which needs to be handled separately, right? Which is things which are commonly known as now secrets. So it could be, credentials, passwords, could be things like SSL keys, public or private keys that you want to store and manage or deploy as part of your application. So for non-configured or for non-sensitive data, environment variables work really well, and container management systems have really good support of these. So that's usually the best way to go. You could even, you could put all of this in a properties file and attach as a file, or inject as independent variables as you're deploying and managing environments. For sensitive data, you should start looking at things like, Vault and Keyviz, which are trust stores or secret, credential stores, which are highly secure and highly flexible in terms of being able to deploy environments, bootstrap, these tools with the right credentials, with the right set of things, and then bringing in this data into containers either through a one-time usage key, and you can also control which IP addresses through an ACL or access list are able to use that key, or through by mapping volumes into specific containers which contain these secrets. The other kind of states, that I'm going to cover are not very common, but they're important to think of. So I'll just quickly mention these, and certainly if there's questions on this, we can answer them. So session state is something you will see especially in multi-page web applications, like if you have, applications which are built using struts, or some of the, Microsoft frameworks for IIS and things of that nature, which are multi-page, and you need to store user or have user data which is shared across these pages. So typically in these, and we've kind of maybe dealt with these in traditional load balancers as sticky sessions, but the idea is once a session connection is made to a particular server or a service in a container in this case, you want to always get that user back into that particular session. So we know how to do this with traditional load balancers like HA proxy or others. And certainly as we're looking at containerized system and container native load balancers, there's also ways and there's support for dealing with these, right? So you need to check with the tool that you're using and how you're deploying container, how the networking works, and make sure that the load balancing solution you're using to route requests to your containerized instances can fully support this. Connection state is somewhat similar, and it needs to be thought through. Now, not many applications have this, but some applications may have stateful protocols. So a good example of this is WebSockets, right? So although HTTP is stateless, and WebSockets is a protocol that builds on HTTP, WebSockets itself is stateful, because once a connection is made, there could be an exchange, a sequence of messages between the two endpoints, right? So that's why it's considered stateful. And the best practice here is once you make that connection, you're not going to switch the next message. Again, in contrast with HTTP, you can't route the next request to any available server. You have to nail that connection to a specific service, in this case, running in a container. So once again, this comes back to your load balancing or your service gateway that you're using in your containerized environments, but this is a solved problem and can be managed. The pain threshold of messaging or managing this varies. So if you do use traditional systems, you have to keep them up to date with container addresses, etc. If you're using container native systems, this becomes a lot easier and pretty much, again, is a solved problem. The last type of state I want to talk about is cluster state, right? And this you're going to deal with. We were working with one customer which actually took an open daylight, an SDN controller and containerized it, and it's highly, in some ways, there's a lot of cluster state and information that needs to be exchanged for that, but more simpler examples are things like MongoDB or even RabbitMQ or other tools like Postgres, MySQL. All of these databases work in some sort of clustered mode, as well as messaging tools work in these mode. So typically here, every member of a cluster needs to share some information, and that's what you need to make sure gets handled. So many orchestrators like Nirmata and others have full support for it. Kubernetes just recently introduced a feature called PetSet, which is starting to support these clustered mode. It's a little bit difficult to do if you're using systems like Mesos and others. This is harder to do, but they have a different way of supporting this, which is through their frameworks and schedulers. So you would need to check with those, if those exist for your application or your backing service that you're using here. But once again, in most cases, it's a matter of either the orchestration system being intelligent enough to know that this is clustered software, and how to deal with making sure membership state is properly propagated to every member, and more importantly, if changes need to be made, allowing the flexibility to update each member in a cluster.
Hey Jim, we have a question on microservices. A question is, would microservices fit better in a Docker infrastructure or a conventional VM architecture? And I guess there are examples of both, but what's, I guess, preferred way going forward according to you and what you've seen with customers?
Yeah, great question, right? And certainly microservices do not need containers by any means, right? You can take microservices, you can deploy them in VMs, and in fact, companies like Netflix and others who pioneered microservices started out using AMIs. However, there are significant advantages to using containers for microservices. And the pairing of microservices and containers is great, because you can truly, again, you can control very well what that microservices needs, how it's deployed in a single container, and that agility that we talked about in the DevOps lifecycle is a huge benefit if you start using containers and microservices together. So they certainly, I feel they're stronger together, but you don't need one for the other. You can either start with containers for traditional applications, and similarly, you can start with microservices on VMs. The advice that we give to our customers, and as most of us are moving from traditional apps to microservices or cloud-native apps, we think containerizing first is a good start, because it introduces a better way of automating and managing your DevOps and CI/CD lifecycle, and then slowly evolving or transforming your application to microservices can come later, and that's a bigger engagement. It requires more thought leadership in terms of deep diving into the application. It requires changes in the application, which is typically harder to do. So we covered 5 different kinds of state, and which are common in applications, and I showed you how each one of those can be managed in containerized environments. So certainly my hope here is that you kind of walk away with some understanding of that stateful applications can be containerized. It's a matter of, it's a combination of getting the right management and orchestration system and using some of the other techniques for dealing with these types of states. The most common, again, are persistent data and state, as well as configuration state, but there are a few others like the connection state, as well as sticky sessions, and it's a cluster state that you would need to think about. So what else is required, right? And like I mentioned up front, we're not going to have time to go through each one of these in details in this session. We are going to do a quick poll at the end of this after Ritesh goes through the demo to see what we should cover next. But certainly there are, once you have figured out application state, you're in good shape. You're about, I would say, almost like 70% there in terms of what needs to be done. Some of the other questions around this are, how do you want to choose what networking option, right? Do you go with the default bridge mode? Do you use, overlay with things like VXLAN, or even can you use VLANs with networking? Does it work with your existing networking infrastructure, etc.? Or do you need a networking plugin? So that's something you need to think about based on how the networking works for your current application and what you want to do moving forward. Similarly, on the storage side, we talked about why you might want to choose, host storage in some cases, when you might need, in a fewer cases, you might need the shared storage or network storage. And there are, of course, volume plugins out there which help with some of the storage orchestration management. So deciding and picking what solution you need. Finally, and quite important, is on the security side, is how do you want to manage privileges on your hosts? How do you want to manage host and network segregation? Do you want to put a big shared pool of hosts with one network, or do you want networks specific to environments and applications? And similarly, do you want to segregate hosts for applications and environments? Similarly, on access controls, does your management orchestration system provide the right access controls and checks all the way through the stack? How are you going to manage secrets? What do you do with image scanning and signing? Is that something you need right away, or is that something that comes later, right? So these are some of the other questions you would want to go through. And again, each one of these could be a complete session in its own, and we're happy to schedule these based on what the community wants to hear about next.
So Jim, this looks like a lot, but for anybody starting out, it's probably overwhelming. So what do you recommend to customers? How do they kind of incrementally approach this?
Good point. There is one thing about the whole container space and ecosystem is there's no lack of choices, right? So there's so many things you could look at and do, but where do you start, right? There is an easy way, and it's something which I guess seems obvious once you think about it, but most likely today you have solved all of these problems for virtual machines in a private cloud, or you might have solved these for public cloud instances if you're using AWS, Azure, or others. So why not just start with that, right? So make sure that your orchestration management can segregate your hosts and network, and start by doing containers in VMs. Of course, if you're using public cloud, this is what you're going to be doing anyways. So you can keep your networking and your storage and your security for the most at the VM layer, but then manage containers and get all the benefits of what you would get by containerizing applications by doing containers in VMs. So that's the incremental or easy way to get started. You don't have to solve all of these up front to get started with containers, but you could solve the few critical ones, get your containers going on segregated pools of VMs, and then over time evolve to a much more cloud native shared cluster type of approach where you get all the benefits containers can provide. All right, so let's switch to the demo, and we'll come back and do some more Q&A after that.
So let's start with the demo. So for this demo, I've picked a traditional application. It's a Spring Java application called Pet Clinic. Some of you, if you've used Java in the past, you might be familiar with it. It's a, you know, two-tier application, a web app that runs in Apache Tomcat and uses a relational database. Has a couple of different options for database, in HSQLDB or MySQL. Um, I have posted the link, obviously, to the project, Spring project, but also on our GitHub site, we have the Docker files that for this application. So you can take a look, and I'll walk you through some of the concepts. If you want, to kind of try it out, you can, we have a package blueprint within Nirmata, so you can try it out. But I'll walk you through the steps. So let's first quickly take a look at the application, right? So it's a Java application. Let me bring it up on the GitHub side. It's a standard Java project using Maven to compile a WAR file. To start with containerizing this application, what you need to do is first create a Docker file. So what I've done is actually started a Docker file, created a Docker file here, which uses a base image, Tomcat base image, and this Tomcat image comes from the Docker repo, which is, I guess, a scanned, secure image or trusted image, as they call it. On this, to this image, I'm adding a few packages, basic packages that are needed for this application. This may vary depending on what you're trying to containerize and deploy. And then I have a couple of other things I'm adding to this image. One is just a run script and the WAR file that gets generated as part of my build, right? So it's called just petclinic.war. So let's look at the run script. Very straightforward. Just does some basic, setup for Tomcat. Creates an admin user, and then just calls catalina.sh to run Tomcat. So that's for this application, that's all I needed to do to create the image, basically, or the Docker file. To actually create the image, I need to run the build command. So once I do that, it'll go through the Docker file and create my image. I can see my just created, this is my pet clinic image. And in this case, it quickly went through it because this image was cached from my previous build. And then once that is done, I can just, using Docker run command, run this image, right? So now I have this image, Nirmata, the pet clinic image, or actually, okay, yeah. So this was my pet clinic image that I had created previously. It runs it, and I can through my I can bring it up. And that's it, right? So it's up and running, in my container. I can see, through Docker commands, the log file. Really, this is a single monolith application packaged in a container. The database as well as the application itself is in a single container, right? What we talked about, what Jim mentioned, is how do you now separate the state out. In this case, it is using the default HSQL database. So, and if I look at my my application, the Spring application, it has a bunch of properties files, and there's a data access properties file which by default uses HSQL database, which is in memory. Now, in reality, or if I wanted to externalize my state, I want to use an external database, something like a MySQL. So what I'm going to do next is go to Nirmata and kind of deploy this application and actually import this application blueprint and show you how you can deploy it or what it looks like when you split this application into two different components, one with the data for the database and the other one for the application itself. So like I mentioned earlier, this is I'm currently logged into Nirmata. In our account, you can actually see we have a bunch of applications in our catalog. The pet clinic application I've already put to added on our in our catalog, and it's also available on our GitHub site. So what you can do is just import this application, and as soon as this application is imported, you see the components of this application. So the two components are the pet clinic, the application itself, and the database. So let's walk through what the database configuration looks like. As you once you have the image, you want to provide some configuration to kind of make sure that the database runs for your needs. You want to set up the networking, make sure you expose the right ports. In this case, I'm kind of violating one of the rules in terms of exposing the password. But like Jim mentioned, you could use in your environment, you could use KeyWiz or some other solutions to pass in the secrets. And then I've added some health checks to kind of determine when this container starts up. Another important aspect is the volume. So Jim kind of walked through the different options to store your data. And here I'm actually mounting a volume from my host into the container so that my data is persistent. And then for the pet clinic, the application itself, the one thing I'm specifying here is a dependency on my MySQL container, so that the order of orchestration is defined, and the pet clinic application is deployed after the database is up and running. And a lot of the stateful applications need that. They need the database up and running, and so your orchestration solution needs to be able to handle that. Networking, pretty straightforward. I'm using bridge mode with port 8080. Now in run settings, one thing you'll see is, again, Jim mentioned the configuration state. What we are doing here is injecting the database information dynamically into the container so that the application knows where to connect to the database. Now, you notice I'm using Java properties. These properties override the settings within the application, so the application will use MySQL database versus the other HSQLDB. And then the rest is pretty much default. So let's go ahead and try to create an application or deploy this application into an environment. So I'll use deploy this to a demo environment. Click finish, and you'll see at this point, it's pulling the image for the database, and checking, doing a health check. Basically, it takes a few seconds for the health check to succeed as the database is coming up. And once the health check succeeds, it's going to start deploying the other, the pet clinic container, and now it's done. I can quickly go in and look at the various log files to see what's going on. Here the database has started, and the other log file I can see for my application, it's actually bringing it up, and you can see it's going to stream the logs. And now I can pretty much go and check if this application is up and running. So depending on how long it takes to initialize, it may take a few seconds to come up.
So Ritesh, that looks pretty cool, but what if I want to now scale my tiers, right? So in production, I might want multiple instances of my application tier and maybe multiple instances of my database. So what do I do there?
Yeah, so that's a great point. And right now, you have a single instance of the application. You can actually see here. I can pretty much, it's up and running. I can add some, data here, and this should go to the MySQL database. So if we restart the database, the data would be persisted. Now, one thing you would want to do as you want to say scale up the application. First thing is to kind of deploy a gateway or a load balancer or Nginx or something in front. So in Nirmata we have our built-in gateway. So I'm going to just quickly show, I'm just going to add it to my application blueprint with some default settings, and then go to my environment, and then add that gateway to my environment. Right. So I'm going to pick the latest tag, just add it to my environment, and now what I have to do is tell my gateway what to route requests or how to route requests. So at this point, I can create URL routes for my application. I'm going to say for /pet clinic, go to the pet clinic service running on port 8080, and the target URL stays the same. Notice if you had, if you want, you can use sticky sessions to kind of just make sure that your requests go to the same container. Now notice once this is done, pretty much from the gateway, you can access the application. So this is the gateway URL, which is different from the application URL, and you can access the application. And now I can scale my service up. I can say, okay, instead of just one instance of my pet clinic container, I want let's say 2 of them. And as soon as I save, it's going to go and spin up another instance of the service. We should see that happen shortly. And then the gateway will load balance across these services.
That's pretty cool. So do I need to go update the gateway at that point, or what happens?
No, at that point, the gateway now is aware that a new container was deployed for this service, and it's automatically updated. So that's one of the benefits of using an orchestration system, which kind of takes care of that, versus actually versus writing some scripts to actually do this yourself. So you can see now the pet clinic service is being deployed. It's pulling an image. In a few seconds, it should be up and running, and the gateway should now start routing traffic to it. Obviously, there's no way for us to tell, but I'm going to refresh the gateway, and maybe what I'll do is try and see if it's talking to this. We're talking to the same application, through the gateway, because I added the myself as one of the owner in Spring application. We can see through the gateway if we can find that. So we're just a couple minutes away, but if you guys have any questions, please start posting them. So see so I can now through this accessing the application to the gateway, I was able to retrieve the same application, same information, and that kind of shows that we're talking to the same application on the back end.
Cool. All right, so let's do this. Let's quickly wrap up, and we want to keep on time just for everyone's schedules. But then what we'll do is Ritesh and I will stay on, and we will we can help answer any remaining questions. So feel free to stay on if you have time. But if not, we can conclude the session. So just to quickly recap, what we wanted to show here is any traditional stateful application can be containerized. There are big benefits in going towards containers for both third-party applications as well as and more benefits for applications which are custom developed, right, where you're going through a DevOps lifecycle. The easy way to get started is try thinking about containers on VMs. Use an orchestration management system that gives you the right access control and segregation at the host and network layer. and then you can over time start using the best practices for security, for networking, for storage, and for other things based on your application and your DevOps needs. So thanks again, everyone. We're going to do a quick survey. So we'll do a survey to check on, what the interest is for our next online session. We're also going to do meetup in person in September in the San Jose area. Seems like we're having some difficulty with the survey, so just reach out to us, and let us know what you want to see as the next session between the networking, the compute, the storage, and or security, right? And we're happy to kind of coordinate accordingly. So what Ritesh and I will do is we'll stay on. And Ritesh, are there any other questions on chat right now, or?
Let me see. Yeah, I think there's several questions on slide. We'll be sharing the slides after the meetup, so stay tuned. We'll also we've recorded the video, so we'll be sharing the video as well. I think one question that came up was on Nginx load balancer. If one container is killed, what happens, and how can additional will the load balancer route traffic to the new cluster, or will Nomad create a new container? I'm not sure if this is talking about the Nomad orchestrator, but really this is kind of what we showed in our demo. So most orchestration systems do that.
Yeah, and if you're using Nginx, of course, there's some specifics. We have seen both, people just take Nginx files and use data containers and manage those separately. So you could have the Nginx routes and information sort of duplicated across or within each container. Or you could use Nginx's clustering mode and options in their commercial version to support. And we've seen both. Both are possible, or you might want to look at other container native load balancing solutions which provide that built in.
Yeah, I think that's all in terms of questions for now.
All right. Well, thanks everybody, and just definitely feel free to reach out to us anytime. And we'll be happy to answer any other questions that come up. We'll also be planning next sessions. So thanks again. Bye-bye.